So this problem says, so here's find V1, I2, and I3. Okay, so V1 is unknown. Anyway, you have three unknowns, and let's look at it mathematically. For three unknowns, how many equations do you need? Three equations. Okay, and the three equations are gotten by using the two Kirchhoff's rules. Okay. All right, so here's a junction. The junction rule tells you the current flowing into the junction is equal to, so these two currents are flowing into the junction, and that current is flowing out of the junction. Okay, so here are the Kirchhoff's rules. Current flowing into the junction is equal to current out of the junction, and sum of the voltages across a closed loop should be 0. Okay, so what we'll do is we'll use this as one loop and that as another loop. You can use any loop any which way you want. It'll give you a equation. Okay. All right. So let's write the current rule. So our junction is this: I1 plus I2 equal to I3. So I1 plus I2 equal to I3. Okay. And I1 is 2 amps. So plus I2 equal to I3. There is one equation. The three unknowns are V1, I2, I3. So when we're solving this circuit, those are the three unknowns that we need to find. Okay. All right. Now let's. So that's the junction rule. Now let's do the loop rule. What we'll do is I'll do loop 1. I'll start from here. Okay. So let me do loop 1. I'm going to start here. Okay. I'm going to go around like this. So I'm going from low to high voltage. So that's V1. The first term is V1. The second term is I'm going with the current. Okay. And R1 is 12 ohms. So with the current, you have a current flows from high to low voltage. So I1, R1. And then I'm going to go across this element. So I'm going from low to high voltage. So that's plus I2, R2. And now I've come back to my starting location. So this should all add up to 0. Okay, so V1, I1, R1 is I1 and R1 are known. I1 is that 2 times 12 is 24, so that's minus 24, and plus R2 is 6 I2 equal to 0. So there's your second equation. Okay. Now we'll have to write down the third equation. We'll do loop 2, and we'll start here and go around like that. Okay. So what I'm going to all right, let me copy this. Okay, so loop 2. Again, we'll start off at this corner and go around like that clockwise. So the first term is I2, R2, and current flows from high to low. So when you go across, that's negative I2, R2. And then you're going from low to high, so that's plus 21 volts. And again, you're going with the current, so I3, R3 minus I3, R3, and that should equal 0. Okay. R2 is 6 ohms, so minus 6I2 plus 21 minus 5I3 should equal 0. 6I2 plus 5I3 is equal to 21. So there is the third equation. All right, so what I'm going to do is I'm going to write down the three equations here. 2 plus I2 equal to 2 plus I2 equal to I3. There's equation 1. V1 plus 6I2 equal to 24. V1 plus 6I2 equal to 24. There's equation 2, and 6I2 plus 5I3 equal to 21. All right, so there are the three equations and three unknowns. Okay, so what have we done? We've done a lot of work, but all we've done is we've using the two Kirchhoff's rules, this rule and this rule. All we've done is use the information in the problem and come up with these three equations relating the three unknowns. Okay? And now it's a mathematical problem solving these things. Okay? Three simultaneous linear equations in three unknowns. Okay? Now all the techniques that you learn essentially amount to this. Okay, so three equations, three unknowns. What you have to do is reduce it to two equations and two unknowns, and then reduce that to one equation and one unknown. And that's the only thing I know how to solve. Okay, so that's what it amounts to. So 5x equal to 15, for instance, x would be 3. Okay. So let's do that. So now we are going to try and solve this. Okay, so you can notice right away, I2 can be expressed in terms of I3. So we'll put that in there, and then you'll get an equation that involves only one unknown. Okay, so we'll take information from here and put it there. So actually, let me grab these guys. Okay, so we'll take information from 1 and put it in 3. So I2 6, I3 minus 2 plus 5 I3 is equal to 21. So 11 I3 minus 12 equal to 21. I3 is, that's 33 divided by 11 equal to 3 amps. So there is I3. Okay, and from this equation, I3 is I2 plus 2, so I2, that tells us I2 is 1 amp. Okay. And now we can put that information here and calculate V1. Okay, so we'll put that information in 2. V1 plus 6 times 1 amp equal to 24. So V1 is 18 volts. All right, so we have our answers. We have solved the equation. There were three unknowns in that circuit, and we've solved for all three. Okay.